this is my favorite U substitution problem because there is a hidden step. The hidden step is easy to get to, but if you don't have this kind of experience, especially on exams, you will be sitting on your chair and feeling hopeless. Right, let's get straight to the problem. The first one, we have integral x times x plus 2 raised to the 6 dx, right? Most people will say, well, there is a composition function, x plus 2 to the 6. I will just let u equals to x plus 2. Yes, you are correct. And then du is equals to dx. The thing is, you are not able to get rid of the x in front. So you will just get integral x times u to the 6 du. Is this correct? This is all wrong. No. There is a hidden step to get rid of the x. So let me show you what that step is. You have to take a look at the u one more time. So u equals to x plus 2. So what does that mean? That means x equals to u minus 2, right? So now you are going to do two substitutions. So let me erase that. You are no longer have an x in front. So this is the integral. So that was supposed to be an x, right? So x is now u minus 2. And then how about the x plus 2 raised to the 6? You already let the x plus 2 equals to u. So that is a u to the 6 du. And then you distribute the u to the 6, so you have integral u to the 7 minus 2u to the 6 du. So this becomes a simple power rule. So add 1 to the 7, so that's an 8, right? And then 1 divided by 8, add 1 to the 6, that is a 7, 2 over 7. And then plus c, you are partially done. And then the very last step is, so that is 1 over 8, x plus 2 to the 8 minus 2 over 7, x plus 2 to the 7 plus c, and then this is your final answer. Okay, so let's take a look at number 2. So number 2, we have integral x squared and then 3 minus x raised to the 8th dx. So obviously u is equals to 3 minus x and then du, that is equals to negative 1 dx, right? And then you have negative 1 du equals to dx, and then you are going to do a change of variable. So you are going to replace this with negative 1 times du. Okay, so looks like you have integral x squared and then times u to the 8 and then negative 1 du, right? Is this correct? No. The differential is du. You are not allowed to have an x squared. So how do you get rid of the x squared? So here is how you get rid of the x squared. Right here. So the first step is you have what is x equals to. So x is equals to, actually, you know what? The parentheses. Let's go like that. X is equals to, so just swap the u and the x. So x is equals to 3 minus u, right? And then x squared is equals to 3 minus u squared. And then you are going to put that right over here. You will be replacing this piece over here. Okay, and then let's erase the x squared. So the x squared is now 3 minus u squared. So 3 minus u squared. Okay, and then what's next? You have to open up the square and then distribute the 8. So that is equals to, so this is a 9, right? Minus 3, that is a minus 6u, and then plus u squared, and then u to the 8th power, and then you have your negative 1 du. And then distribute the u to the 8. You can pull the negative 1 out. So you have 9 u to the 8th minus 6 u to the 9, and then plus u to the 10. And then du. So just integrate term by term using simple power rule and keep the negative 1 outside. So this is a u to the 9. And then this is a u to the 10. You have a 6 over 10. And then this is a u to the 11. 1 over 11. And then you have the whole thing plus c, right? So distribute the 1 and then put the x back. So you have negative 3 minus x to the 9th power plus 6 over 10. So that will be a 4 over 5, right? And then 3 minus x to the 10th power minus 1 over 11, and then 3 minus x to the 11th power plus c, and then this is done. All right, let's take a look at the next one. The next one, the hidden step, is very tricky. So moving on to the last problem. The last problem is integral x to the third and then x squared minus 3 raised to 3 over 2 dx. Okay, so first of all, and then you let u equals to x squared minus 3. So du is equals to 2x dx, and then 1 divided by 2x du equals to dx. Of course, that is not enough to get rid of the x to the third. Right? So let me move this step down, because I'm going to show you the hidden step. The hidden step, let's do it in a different color. How about this? Let's do this in this color. So this one, this has an x to the third. We have 1 over 2x. That is not enough to get rid of the x to the third. So what we are going to do is, I am going to take this u, and then first, let's put the x squared on one side. So we have an x squared equals to what? Equals to u plus 3, right? So equals to u plus 3. So that is a step that we will have to do. And then the other step is, I am going to have to take the, I'm going to rewrite this step a little bit. So what I'm going to do next is, you have 1 over 2x and then du dx, right? Look here, take this step and then do one more hidden step. You have to toss the x to the other side. So 1 over 2 du equals to x times dx. Just toss the x to the other side. All right. Okay, now let's put all the pieces together. So the original problem, let's first rewrite this problem as this. So we have integral x to the third. I am going to put this as x squared and then times x. Just break the third power into a square times x. No change on the dx, and then the piece in the middle, that is x squared minus 3 raised to 3 over 2, right? Okay, how do we rewrite the x squared? So here is the x squared. So the x squared is right over here. So let's use arrow. So this is your x squared. And then what about my x dx? So the x dx goes here. So this is the x dx. And then we have a u raised to the 3 over 2, right? Okay, let's put all the pieces together. So we have the x squared becomes u plus 3, and then the next piece is u raised to 3 over 2, and then the x dx is a 1/2 du. So this is a 1/2 du. Do you see that there are no more x, right? Okay, distribute the 3 over 2, so we pull the 1/2 in front. So this is a u. 3 over 2 plus 1, that is a 5 over 2. And then 3 times u to the 3 over 2. And then du, so integrate term by term. And then this is a 1/2, so you have a u. 5 over 2 plus 1, that is a 7 over 2 reciprocal. And then plus 3 over 2 plus 1, that is a 5 over 2. And then reciprocal times 3, so we have a 3 times 2 is a 6. And then the 5, right? So if you take derivative, you can easily get the integrand back. Right? So bring the 7 over 2 down, 5 over 2. Bring the 5 over 2 down, you have a 3, and then 5 minus 2 is 3. All right, so let's put the x back. So the x, what do we have? We have 1/2 times that. Distribute the 1/2, we have a 1 over 7. The x is x squared minus 3 raised to 7 over 2. And then plus distribute the 1/2, you have a 3 over 5. And then this is a x squared minus 3 raised to 5 over 2, and then plus c. So this is done. This is the final answer. Alright, so is this helpful? I might save you 10 points. If I save you 10 points or more on the test, let me know in the comment below. If you like it, share, subscribe. I will see you all in the next one. Signing out.